All right, so for this, we're just trying to get our axis of symmetry. That's when we're using that AOS. We talked about that on Monday. It's also still on the board. It's x equals the opposite of b over 2 times a. It's how we find the middle of our table if we're going to graph it. Oop. Oop. So for a here, our x is the opposite of our b. B is right here. So it's 18 over 2 times the a, which is the number in front of the x squared. So right here, there's an invisible 1. So then we're going to simplify this. X is negative 18 over 2 gives us negative 9. That is our axis of symmetry. Good pen. Can we not be a jerk about it? There we go. That's our axis of symmetry for 1. Or A. I forget how I marked it down. Same kind of vibe for B. We're going to use our B term, we're going to use our A term, and we're going to set it up. Oh, I don't like that gray. It's really hard to read through. We'll do the green. There we go. So we're going to have, ooh, that's not a pen. X equals the opposite of B, which is 9, over 2 times our A, which is 2. Opposite of B over 2A. So this gives us x equals, and what does this simplify down to be? Yeah, negative 9 over 4 or 2.25. As we're typically working on this on a graph, I'm fine with either way. I don't care if we do it as a mixed number or as an improper fraction or as a decimal. I don't care. I genuinely don't. So negative 9/4 or negative 2.25. I don't care. More often than not, if we're actually working with it on a graph, it'll be a not awful number. I'm not going to ask you to graph a third or something. All right, again, we're going to take our B and we're going to take our A, and we're going to put those together. Wait, forgetting to switch to a pen. So our x equals the opposite of B, so the opposite of negative 12 over 2 times 3. The opposite of negative 12 is what? What's the numerator going to simplify down to? Just 12. And the denominator is 6. What is 12 divided by 6? 2. So this is our answer here, and this one's our answer here. So being able to find that axis of symmetry is going to be one of those things we use bunches and bunches and bunches. Questions? Okie dokie artichoke. So we're going to go into notes, and we are going to do a quick refresher on the transformations. We have used these before. I pointed this page out for you, so you don't have to like rush to sketch it. So this is going back through our transformations. That's substitute from the formula. We have used these before. It's A, H, and K, the same ones from our absolute values. So these transformations are the same exact ones. Oh, and I'm good at counting, y'all. There we go. All right, so these are familiar. You've worked with them before. We've got A, H, and K. It's the same A, H, and K from when we did our absolute values, from when we started working with transformations of general functions. Same A, H, and K. It's just this, like, writing it all out specifically. So our A is always out in front, and A has two transformations it can do, two jobs. If A is negative, that's when it makes it flip, makes it reflect. Oh, I'm going to write it in purple. If it's negative, it reflects over the x-axis. Again, we're only going to see an x-axis reflection until we get to, like, April. So we're only going to see x-axis for a very long time, but we're just going to be in the habit of being specific. If the A is bigger than 1, that's when it's doing its big kid yoga, and it's going to stretch up really, really tall and really, really skinny. So if A is bigger than 1, the graph is stretched. And if A is little, it's between 0 and 1. It's just so little and cute. I want to squish it. It's going to compress. So little and cute. I want to just squish it. Is compressed. So it's just written out really mathily, where it starts as the absolute value of A is greater than 1. If the number is bigger than 1, it's stretched. If the number is between 0 and 1, it's compressed. If the number is negative, it reflects. So then we're going to have our H. H is always inside our parentheses. H, for all of our groups, all of our transformations that we're going to use this for from now until May, H is always inside your expression. And it always, always, always has the opposite sign, which I'm going to squeeze that in here, sign of what you see in the parentheses or in the expression. It's always the opposite sign because it's the H opposite. And this tells us if the graph is going left or right. If H is negative, it goes left. If it's positive, it goes right. And that's what this blank is saying. It's shifting right H units. Bless you. Bless you. Then we have our K down here at the end. K, that's our vertical shift. So K is in charge of how high it is. So if K is positive, K is bigger than 0, it's going to go up. If K is less than 0, it's going to go down. So this page is going to be a really handy reference for you for this chapter. I recommend not throwing it away because we're going to use A, H, and K. A, H, and K always have the same jobs. For no joke, every kind of function we're going to do all year long. Every single one has A, H, and K. Every single kind of function. So A, H, and K are one of those things that we're going to use enough times, you're going to wind up with it memorized. If you want to do it intentionally, more power to you. But it's one of those things we are going to use bunches and bunches and bunches and bunches and bunches and bunches of times. Okay, I'm going to leave this up for just another minute or so. Okay, so this is what we're going to start with. We're going to start with finding our A, H, and K and saying what the heck that means. So that's step one. And we're going to do it with all three of these equations. I'm going to put our transformation form up here on the screen. So y equals A x minus h squared plus k. And what we're going to do is we're going to find out what A is, what H is, and what K is, and we're going to name them. That's our first job. So on this leftist one, we're going to try and find A, we're going to try and find H, and we're going to find K. So our A is always out in front of the parentheses. So for this one, what we have out front is what number? -1. For my H is always inside. And with the opposite sign, so it's going to be -7. And K? -3. So we're just identifying those pieces right now. What does an A value of -1 tell us is going to happen? Yeah. It tells if it's going to reflect, stretch, or compress. Which ones is it going to do for an A of -1? Reflect, and only reflect. So this will reflect over x-axis. Yes, dear. Because it's negative. If A is negative, it reflects. If A is negative, it will reflect over the x-axis. And that just means it's going to go upside down. How about H of -7? Which direction is that going to go? Left. I heard it. So it's going to go left 7 pieces. So we're just going to pick it up and we're going to go blunk, 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 blunk 7 times. How about a K of -3? What's that going to make it do? Down 3. So that's what it means when it says identify the transformations. Just writing it out like that is plenty. Somebody's music is on loud enough. I'm hearing it over here. I'll find the headphones if I need to. Same process over here. We're going to find our A, H, and K. So what do we see? 2. Yep. -3 and +4. So A is out in front. Every single time it's 2. What is that going to mean transformations-wise? It's a stretch. If it's bigger than 1, it's a stretch. What's our H value? Yeah, it's 3, but we got to be careful because it always has that opposite sign, so it should be -3, which means it's going to go which way? Left. That is the worst arrow I've ever drawn. Let's try that again. There we go. So this one's going to go left. Let's see, it's over here. I'm trying to figure out which one of you it is. One of you, I can hear it at my desk. All right, what's our K? 4, which means it's going which way? Up. It's going to move up 4 spaces. Left 3 spaces, and it's going to be stretched. One more like this, and then we're going to kick it up a notch. You know, our favorite phrase. All right. So what is our A value here?
1/4.
It's 1/4, which means what's happening transformation-wise? Because it's just so little and cute, I want to squish it. It's compressed. What is our H value? 10. It always has that opposite sign. Oh, just color it in. Oh, I hate that. Which means it's going to go which way for a +10? It's going to go right. How about our K value? Up 13. So it's going to go up 13, right 10, and it's compressed. Questions on the identifying part of this? Because we're going to be using these to make the graph. So the identifying of the A, H, and K is a critical part of graphing these in this kind of form. All right, then shock of all shocks, we're going to do a graph. And you're going to do 2 graphs, which I don't have a specialty graph for you. So I only have sets of 3, so sorry. You can either glue all 3, or you can cut off one of them. So we're going to be graphing our vertex form. Yeah. All right, we're only going to do 2 of these. And our first step when we're graphing these from our vertex form is to find our A, H, and K, just like we just did. So we are going to find A, H, and K for this equation here. What is my A value? Nothing. So if there's nothing multiplied out in front, what number is that going to be? Not 0. 1. because there's nothing multiplied out in front. If it was adding, then it's 0. But if A is not there, it's just an invisible 1. How about our H value? Positive 2. And our K? Negative 4. So what we're going to do is we're going to do this transformation style, just like we did for the absolute values back in chapter 1. Where we would make our parent table and then we'd apply our transformations. The parent table involves our parent function for quadratics, which is when we think about x squared. That's the parent function. We pick some x's to find some y's. And we're just going to think about x squared first. We want a good view of the middle of our graph. So we're going to take that same chunk from the middle that we did in absolute values when we went from -2 to -1 to 0, 1, and 2. And we're going to say, all right, my y values are whatever -2 is squared. What is -2 squared? 4. What is -1 squared? 1. 0 squared? 0 times 0 is just 0. 1 squared is 1. And 2 squared is 4. This is our parent table for quadratics, for x squareds. The parent table doesn't change. It's going to be the parent table. It is the parent table. It will forever be the parent table for quadratics. If we see this little 2 up here, this is our parent table. What we're going to do to find the graph we want to draw is we are going to take our parent table and apply the transformations. We're going to do our x plus my h and my y times a plus k. It's the exact same setup we had before. So in this case specifically, I'm going to take my x values and add 2. X plus h. These x's plus h. So when I take -2 plus 2, that gives me 0. -1 plus 2 gives me 1. 0 plus 2 gives me 2. 1 plus 2 gives me 3. And 2 plus 2 gives me 4. I take my x's, I add my h. Then we're going to take our y's. Y times a, so we're going to go times 1 plus k plus -4 or minus 4. So the times 1 isn't actually doing anything. So we just need to think about the -4 in this case. So we're going to have our 4 times 1 minus 4 gives me 0. 1 times 1 minus 4 is minus 3. 0 times 1 is 0, minus 4 is -4. 1 times 1 is 1, minus 4 is -3. And 4 times 1 is 4, minus 4 is 0. And this is the graph we're going to draw. So we're going to plot those points. So we have our 0, 0, 1, -3, 2, -4, 3, -3, and 4, 0. And once we connect them up, we get our parabola. There's some really cool things going on here and to why this is called vertex form, because we can see on our picture that our vertex is right here. We also have our vertex right here in the middle of our table. We also have our vertex right here. Our vertex is always going to be H, comma, K every single time. That's why this is called vertex form, is it's inbuilt in here that this guy and this guy tell us our vertex. It's there. They're right there written out in front of us. So H and K are our vertex points. H, comma, K is the vertex. So then let's think about our domain. What's our domain for a parabola? All real numbers. And that's true for all parabolas. Our domain is always going to be all real numbers. How about our range? Yep. From -4, square bracket, to infinity. Our range is always going to involve K in some way, shape, or form for a parabola. Hello. Thank you. Enthusiastic. Sandra. Yes, dear. So the domain is what's our leftist and our rightist points. How far out does it go? So what is the farthest left it can go? Does it ever stop? No. So it goes all the way to negative infinity to positive infinity. That's our other way to write it. Okay, let's do one more like this. It's got the fractions. This is to, yeah, you got something to pick up at the front desk. You can go now. That's totally fine. Yeah. Take that with you because that's your pass. All right, same vibe. We're going to find our A, H, and K. We're going to plot our graph, all that jazz. So what is our A? -1/3. And we go, that's okay. We can do it. -1/3. That's my A. How about my H? Is -3. It always has that opposite sign of the expression here. How about my K? Is -3. A couple of -3s here. Lots of minus signs going on. Everybody's negative. That's okay. We can do that. Our parent function is exactly the same. So it's that same parent function we had on the last one. It's an x squared. So we've picked x's to find y's. We take that good view of the middle from -2, -1, 0, 1, and 2. That same good view of the middle of my parent function. That's giving us 4, 1, 0, 1, and 4. So we're going to do our transformations. The parent table is not going to change. For a quadratic, that's the parent table for now, forever, and for always. We're going to take the parent table and do our changes to it. So we're going to take our x plus h and y times a plus k. That's the wrong color. So we're going to start with adding -3, or just -3. So we're going to take our x values and -3. So -2 minus 3 is -5. -1 minus 3 is -4. 0 minus 3, bless you, is -3. 1 minus 3 is -2. And 2 minus 3 is -1. Our y's here are going to get a little gross. It's okay. We can use a calculator. We love calculators. They're our very bestest friends. Because we're going to take our y values times -1/3 minus 3. Ew. But luckily, we have tools at our disposal to do this. Yeah, okay, I heard you. So we can take our y value of 4 times the fraction (-1/3) minus 3. And we can just type it in like that. And we get 13/3, which is fine, but really hard to graph. So -4.3. So our y value here is -4.3. Gross, but doable. So then we're going to take our y value of 1 and do the same thing, this y value over here. We're going to have 1 times the fraction (-1/3) minus 3. And we again get a fraction, (-10/3). I would like that as a decimal, please. -3 1/3, or -3.3. When my y is 0, you can absolutely plug it into a calculator. With this one, we can do ourselves. 0 times (-1/3) is 0. 0 minus 3 is -3. We've already done the 1. 1 gave us -3.3. We've already done the 4. It gave us -4.3. We will always wind up, or we should always wind up, with symmetrical data here, doing it this way. So what we're going to do now is we're going to plot our points. -5, -4.3, which is somewhere between -4 and -5. When in doubt, make a chunky dot and move on with your life. I'm not going to bust out a ruler and say, well, you said that was a third, but I think that's more like a half. Points. Ew. -4, -3 and a bit. -3, -3, right on the dot. -2, -3 and a bit. -1, -4 and a bit. And we have an upside down parabola. Because my A value is negative, we got that reflection. It's been flipped. It's now upside down. Last two bits for the day are domain and range. What is our domain? What's the farthest left and farthest right? Yeah, from negative infinity to positive. Yeah, or all real numbers. It's going all the way left, all the way right, because my arrows are both pointing out. Our domain for parabolas is always going to be negative infinity to positive infinity. Every single time. Every single time. How about our range? What's our range here? Negative infinity to, what's the highest it goes? What's the highest it goes? To -3. It's always going to involve my k value in some way, shape, or form. Every single time. My range is always going to include my k for parabolas. Okay? Questions on that? That's it for today. So homework 3-1, that one that I gave you guys on Monday, the bottom one on that front page was vertex form. So you can do that now. It's A, H, and K. Find your A, H, and K. Do your transformations. On the back side, there was one like it too. We're identifying our vertex, identifying our transformations, and all that kind of jazz. All right, we got like 2 minutes till announcements.